So monsoon begins from June, right? 1st of June, technically. On 21st of June, which is called as a summer solstice, the sun is exactly over the Tropic of Cancer, right? It's called summer solstice because the sun is over Tropic of Cancer. If sun is over Tropic of Cancer, the insolation the Tropic of Cancer is receiving is very high. So, can I say ITCZ will be somewhere over here? Because insolation is very high temperature, low pressure, right? ITCZ is somewhere over here. ITCZ is an area of which pressure? High or low? Low pressure, because it's converging, right, into tropical convergence zone, and high temperature, obviously low pressure. So it makes sense that low pressure exists here. Now, 23.5, that sounds like somewhere within India. Now, if you talk about the geography here, I'm going to try and draw Indian subcontinent. We have the equator here. Okay. 23.5 is here. But there is something called as a Tibetan plateau here. Tibetan plateau, it is a huge, huge area of just barren rock, completely rock. So here you have some of the highest temperatures because compared to the areas near Tropic of Cancer, the Tibetan plateau, which is completely made out of rocks, which is like a flat level surface, their temperature is very, very high. You have something called as a Tibetan low here. Low as in low pressure, because it's very hot there. You have a Tibetan low there, Tibetan low pressure area. Okay. Now, if that is low, here there are a bunch of islands called Mascarene Islands. This is not an icy Joshi, by the way. It's like a story that I'm telling you guys. There are a bunch of islands called Mascarene Islands. And over here, there is a high pressure system. So that's why this area is called as a Mascarene high. So you have the Tibetan low and the Mascarene high. Now, pressure always goes from high to low. So from the Mascarene high, it tries to go northward. The winds are traveling because wind is nothing but the outcome of pressure differential. Coriolis force southern hemisphere deflects wind to the southern hemisphere is left. So they try to go upwards, but the winds end up going this way. Makes sense? But once they cross the geographical equator, they will be deflected to the right now because Coriolis force in the northern hemisphere deflects wind to the right. Yes, they go this way. This is nothing but your monsoon. Okay, because ITCZ is moving upwards and this is happening. So the wind is coming from which direction now? If you see it in terms of quadrantal points, from this side, this is north, south, east, west. It's coming from southwest. That's why it's called as southwest monsoon. Okay. Now we'll see one more thing here. This is a geographical equator, 0 degrees. This is ITCZ. Whoever is writing, please don't. I know, Sharon, you're trying to move around. It's okay. So this is ITCZ in monsoon season. It's in a slightly northern hemisphere. We have the normal tricellular circulation where you have polar easterlies, mid-latitude westerlies, and northeast trade winds. Below the equator, you have the southeast trade winds. You have the mid-latitude westerlies and polar easterlies. But there is an empty slot here. ITCZ, low pressure. Equator, comparatively high pressure, because ITCZ is the area where there is lowest pressure on Earth. Literally anywhere else the pressure is high. Pressure goes from high to low. So it should technically go this way, but we are in northern hemisphere, so it will get deflected to the right. So wind goes this way. Do you see southwest? This is your southwest monsoon. So just the same thing in a different way. Initially, we had northeast trade winds here, remember? Yes. In this area, we had northeast trade winds, but now we have southwest. There is a reversal of winds happening. That is why it's called as Monsoon. Monsoon is basically reversal of Monsoon. That means reversal of winds. Initially it was northeast, but now it's southwest. That's why it's called monsoon is nothing but a reversal of winds. Make sense? So draw this in your notes or whatever, wherever, and then we'll continue with what is happening.
Recording in progress.
So that's monsoon. That's how it approaches. And as you can see, you have a lot of rainfall and everything. So there are a lot of isobars here. You had 4 isobars in winter, 2 in summer. You have 6 isobars during monsoon, right? As you can see here. And it makes sense that the higher pressure monsoons are higher pressure isobars are here in the lower part of the country, and low isobars are here because its IT season is here, and it makes sense that low pressure is over there, right? So there is one peculiar thing that is there in ISO monsoon. What is wrong with me? There is something called as a monsoon trough, which is a trough during the monsoon season. Do you see this isobar in the textbook that looks like this? This is a trough because this is 9 or 8, whereas isobar that is after it is 1000. The extension of an isobar where pressure is lower than its surroundings. So monsoon trough, important focus. This is called as the axis of the monsoon trough.
Recording in progress.
This is called as the axis of the monsoon trough. This trough begins somewhere near Rajasthan. Okay. The place given is called as Ganganagar. Ganganagar is like the northernmost district of Rajasthan. It begins there. And the axis of this trough goes on until Head Bay. What does Head Bay mean? Head Bay means, yesterday we saw. Head Bay. Bay is Bay of Bengal. Head Bay means northern part of Bay of Bengal. Seen this yesterday. Where are you? What were you doing yesterday? Anyway, there are again bunch of isobars here on the western coast, and this is a shallow ridge to be so this is 1002, 1004, 1006, and 1008. So isobar probably would have been this way, but it's an extension where the pressure along the ridge is higher than its surroundings. So you have a shallow ridge in the western coast or along the western coast of India. You have a monsoon trough along the Gangetic plains here because this is the Ganga River, Gangetic plains. You have a low pressure system here over Pakistan, as you can see, and another low pressure, a weak low over Myanmar. Right? This is the pressure distribution. There are 6 isobars in total. Surface winds are obviously southwesterly because it's literally southwest monsoon. Upper winds. Which jet stream affects India in monsoon?
Monsoon. Australia.
I've told this again and again and again and again.
Subtropical.
Monsoon, odd one out, tropical easterly jet stream. Always. So upper winds are easterly because of the, I was literally explaining it with summer also, that summer subtropical goes up, tropical easterly comes into picture because of monsoon, right? So tropical easterly jet stream means the upper winds are easterly. The position of tropical easterly jet stream is prominent here, especially in the southern part of India. And at approximately 13 degrees north, this is Chennai's latitude, is where it is, its average position is there. Subtropical jet stream, tropical easterly jet stream. Which one do you think is more stronger in terms of wind speeds? Subtropical, because first it is continuous all around, right? And this tropical easterly jet stream is also something that is there only for 4 months. In the duration of monsoon, its speeds are low compared to subtropical jet stream. Now, if you've ever watched these news reports of monsoon, they or articles also come out that monsoon has been delayed, or there is an early onset of monsoon or late onset, monsoon has been delayed, so and so on, so forth, right? So how does that work? How do you know if it's delayed? Like, does it mean 5 o'clock it should be here, 5:10 it's delayed? Not that way. 365 days are segregated into group of 5 days. 5 days. One group of 5 days is called as a pentad. Pentad. Penta means five, right? Pentad means one group of 5 days. So over Kerala, it is supposed to reach at approximately 1st June or on 1st June, monsoon winds should reach Kerala. Right. Now, if they don't reach Kerala within that pentad of wherever the 1st June is, maybe it's 28, 29 or 29 March, 30 March, 31, 1st June, 2nd June. If it doesn't arrive within those group of 5 days, then monsoon is said to be either delayed or it arrived too early. Right. So onset dates are fixed based on historical data, like in through or along hundreds of years, when did monsoon reach this place? And then these dates are divided into group of five. If they don't reach within this group of five, you have a delay or early arrival. Now, monsoon also arrives in India in two branches, as you can see. There is one which is the Arabian Sea branch, and one there is a Bay of Bengal branch. Bay of Bengal branch would have gone this way had there not been this mountain range called as Arcanyoma. Just like how we have Himalayas in our northern part of India, in Myanmar there is this hill range called as Arcanyoma. This Arcanyoma deflects the wind or monsoon towards India again. Okay, that's why you have 1 second. Why am I not able to move it? So you have the Arabian Sea which goes this way, Arabian Sea branch, and the Bay of Bengal branch also which goes this way. Right. So Kerala, the first state to receive rainfall, especially in the mainland India, Lakshadweep technically, but mainland India, Kerala is the first state. It goes all around. Rajasthan, Punjab, that region, it reaches the last. But when it retreats, it leaves out of that place first, and then it leaves out of Kerala the last. Weather, obviously, we have widespread rains all over. But what happens is, when these monsoon winds reach the Himalayan region, the pressure all across the country suddenly rises a little bit. Okay. There is a rise in pressure all across the country, except for the foothills of Himalaya. See, if these are the mountains, the place where they touch the land, this is called as the foothill region, right? There you have the maximum rain. Everywhere else in the country, the pressure rises. Everywhere in the country, the rain stops because all the rain is now concentrated near the Himalayas for a couple of days and it comes back again. This is called as the break monsoon because the rest of the country is getting a break from the constant rainfall that the monsoon is causing. That's called as a break monsoon, right? Now, we've seen monsoon trough. Also, flying, obviously bad because constant showers, constant cumulonimbus forms, stratiform clouds, poor visibility, rain, turbulence, things like that, right? Now, break monsoon, I told you what happens. Everywhere else, pressure rises. Sometimes you can have mid-tropospheric cyclones as well. The latitudes and longitudes are given between 60 and 80 east and 18 and 28 north at the levels of 500 and 700 hectopascal. 700 hectopascal is 10,000. 500 is, I think, 18,000 or 24? 18,000. 300 is 24. 300 is 30,000. 30,000. 400. 400 is 24, yeah. So between those, you could have mid-tropospheric cyclones forming and which will give heavy rainfall and all that. So if you have a table, you remember we read this one line in tropical systems which said surge and shear lines are a characteristic of vigorous monsoon. That vigorous monsoon is given in this table. If you see four things, you have a weak monsoon, you have a moderate monsoon, you have a strong monsoon, and you have a vigorous monsoon. These are named based on the wind speed and the amount of rainfall. Now, what is normal? Normal rainfall? Again, historical data, right? How many centimeters of rain should you get in certain part of India or in as a whole? And more than that, less than that will determine if it is whichever category of monsoon. Now, ENSO will come back because it's related to monsoon, but it's like a bigger explanation. So what we'll do is we'll look at northeast monsoon and then come back to ENSO, right? See, I said all of this monsoon winds, the Arabian Sea, the Bay of Bengal Sea, they go, reach India, reach the Himalayas, give rain there for a couple of days, and then they start to retreat back. So if this is the Indian subcontinent, they come back this way and they give rain. That's why it's called as northeast monsoon, because they come from northeast, right? This is also called as post monsoon season, also called as cool season. If you see the isobar distribution, technically there is no isobar at all in the Indian subcontinent. There is only one isobar which is going all around the country. However, there is a low pressure off the coast of Tamil Nadu. Right? As you can see, the months are October, November, December. Chennai gets floods every December, right? Every December, first, second week, there's always some kind of flood in Chennai, right? Because of some cyclone. Can I say this low pressure system being here will have something to do with it? Obviously, because low pressure, convection, it's happening over the sea. So makes sense that Chennai and Tamil Nadu coast is receiving. See, the Eastern Ghats and parts of Andhra Pradesh and Tamil Nadu, they don't receive much rainfall during southwest monsoon. They actually receive more rainfall during northeast monsoon, because southwest monsoon here, this branch goes this way. The Bay of Bengal branch, it goes over the Bay of Bengal and this way. So technically, this region is not receiving any rainfall. However, when the recurvature happens, as in when it puts like a reverse gear and tries to go out of India again, it goes like this. So what is happening is these winds, they are traveling over the Bay of Bengal, picking up a lot of moisture and dumping it here. That is why you have cyclones happening during November, December, and floods happening in Tamil Nadu during this time. Okay, but everywhere, the rest of India, apart from leaving this area, you have good weather. Right, as you can see, there are no isobars and not a lot of pressure difference. If there's not a lot of pressure difference, you don't have very bad wind and all that, right? So, surface winds are northeasterly. Again, monsoon is over. Which jet stream will we have? Monsoon is over. Subtropical jet stream. So, upper winds are easterly or westerly?
Westerly.
Westerly. Right?
Westerly.
Now, some facts that Tamil Nadu receives 48% of the rainfall, right? Okay. What were they saying? Westerly. And Tamil Nadu receives 48% of the annual rainfall because of the recurvature and the fact that it's traveling over the Bay of Bengal before reaching Tamil Nadu and some parts of AP. Pressure pattern, only one isobar of 1010 hectopascal surrounds the whole country. There is, however, a weak low pressure off the Tamil Nadu coast, and there is a weak low pressure over the Pakistan area. Surface wind, I've told you, it goes from southwest to northeast. Upper winds are westerly. Surface temperatures are not that hot anymore because again IT season has moved out, and temperatures are approximately 18 degrees. And weather, this is the best period to fly in India apart from the again Tamil Nadu region, because that's where you have cyclones and thunderstorms happening, right? Now, so this is where maximum cyclonic storms also occur. Again, I've told you the reason, right? Aviation hazards during this season. Everywhere else in the country, like I said, all good. But if you talk about this region, you have low clouds, rain, low visibility, turbulence, and things like that. And root winds, see, I just want you to remember this one thing, because this is like a very low hanging fruit all the time. Remember, monsoon easterly, monsoon TEJ, monsoon TEJ, that's it. Any season, be it pre-monsoon, be it post-monsoon, be it winter or whatever, until and unless you only hear one word of monsoon, that's westerly. Monsoon is easterly all the time. Monsoon is from June to September. Anybody's birthday in September? Shayad, Rishi. So from my birthday until the month of both of your birthday. Yeah, yoga day. Yeah. So from June to September, you have monsoon. Anytime you are asked, what are the upper winds during August? August means it comes in monsoon. Monsoon means tropical easterly. Or they'll ask you, when is the intensity of turbulence or CAT most during tropical easterly. Tropical easterly means monsoon. Monsoon is June to September, but maximum actually occurs in July to August. But if you remember June to September, you can remember it. Now, when is the subtropical jet stream maximum? See, subtropical jet stream again is non-monsoon. There are total 3 seasons where subtropical jet stream is there. Subtropical is westerly, but like I said, subtropical or any jet stream, it feeds off of temperatures. It wants lower temperature. Lowest temperatures are in December, Jan, February. That is when the intensity of subtropical is also very high, right? So remember this. You guys keep forgetting it, but it's very low hanging fruit. You cannot make mistakes in things like this. Monsoon taste, that's it. Now we'll come back to ENSO. Have you ever heard of El Nino, La Nina on the news? No. All right. So this is a thing which happens in the Pacific Ocean. Okay. I'm trying to when I draw, use my drawing skills and 1 second. It's gonna take some time, like a minute or so. But malfunction of pencil, the critical time. Australia, New Zealand is something like this. There's Japan, Russia, Sri Lanka, Middle East, and all that. Malaysia, all okay. Okay, this is Japan, by the way. That's said to be Laos, Cambodia, and this is said to be North Korea, South Korea, all that. Anyway, equator goes this way, right? What happens is, we've seen jet stream, right? Jet streams are like these huge rivers of wind which are being transported or being sent or carried from one place to other in the Earth's upper atmosphere. Now, there is a concept called as Rossby waves. This is again not given in IC Joshi. You don't have to remember the names as well, but again, just concept. Rossby waves. A part of Rossby waves are the atmospheric circulation, oceanic circulation. Atmospheric circulation is happening in the terms of tricellular model. Heat is being transported from one latitude to other. There's northeasterlies, westerlies, east. All that is happening. Just like how air is circulating, water or oceans are also circulating, right? Now, there are different circulations like Falkland circulation, Chilean current, there is West African current, West Australian current, is a lot of them. There are like 15 to 20 of them. There is one current or one circulation which is called as a Walker circulation. Walker circulation is just the name given to the circulation of Pacific Ocean that should go this way. Do you see the arrows going this way? This way. It should go this way, Walker circulation. Because there is a high pressure area here and a low pressure area here, generally. That's how it happens. But sometimes what happens is the difference between this high pressure and low pressure increases. When that difference increases, pressure gradient is increasing. Pressure gradient is increasing, winds are faster. That gives rise to excess rainfall in South Asian, Southeast Asian, and Indian geographical regions. Right? That phenomena is called as La Nina. La Nina means the girl. Okay. So you have a Walker circulation that should happen normally, but if that intensifies and gives rise to excess rainfall in the Indian subcontinent or even Southeast Asia or South Asia, you have La Nina. Next, you have El Nino. What happens then is everything reverses. See, this is the Pacific Ocean, right? In this Pacific Ocean, this is Eastern Pacific Ocean, this is Western Pacific Ocean, right? Because of this is Eastern, this is West, yes. Now what happens is, every 2 to 7 years, it used to be that, now it's much more frequent. It shifts. What does that mean? Now you have a high pressure here and a low pressure here. So can I say the Walker circulation will now reverse, right? Now it goes this way. So now which side or which countries or which regions will receive rainfall here? If it's going this way, South America, that region. right? Right? This phenomena is called as El Nino, where there is a sudden upwelling in the Eastern Pacific Ocean, and like there's all this is carried, right? See, upwelling another way is low pressure system, convergence, and ascending. So the sea level rises slightly. That also could be counted as upwelling. A lot of minute things that you can learn from all of this, but the idea is Rossby waves, Walker circulation, extreme Walker circulation, La Nina. Things reverse, you have El Nino. Now, La Nina gives us excess rainfall, correct? At least let's only care about India at this point. We only care about India, nothing else. La Nina gives us excess rainfall, correct? Because it's carrying all that moisture and wind from the Pacific Ocean and dropping it off in the Asian region. So, monsoon and La Nina have a direct correlation. As in, monsoon, you have rain, La Nina, you have rain, you have flood like conditions in India. But El Nino, you have a drought, you have a deficit because all this is being carried to the South American side. Because of that, we have an inverse relationship here. Because monsoon is trying to give rain, but El Nino is taking it away, right? So positive, positive here, positive, negative here. The thing is, every monsoon, the IMD, Indian Meteorological Department, has to come up. Wait, let me see if there's anything else, and then I'll tell this. Inversely related, lasts for some months, La Nina. Okay, that's all. Okay, so that's the technical information or factual information from the book. But every year, IMD, Indian Meteorological Department, it has to give out to farmers about the monsoon data because a large part of Indian farming depends on what the IMD says the rainfall will be like, right? Because if IMD says rainfall is going to be pretty good, maybe they'll put things like sugarcane or rice, which are water intensive crops. But if IMD says we're going to have a drought, then they'll maybe switch to millets or cotton and things like that. So IMD can predict monsoon, yes, but IMD cannot predict El Nino, La Nina. So that is where predictions in the past have gone wrong, and crops, and again, that's maybe like a documentary version of things that we can discuss later. So that is the issue with El Nino, La Nina because these are not, they don't tell you they're happening. At least monsoon is every year. You know that June so and so it will happen. But El Nino and La Nina can affect monsoon in such a way that they can either give you more rain. So let's say whatever crops were planted and suddenly you have La Nina, excess rainfall, they're all submerged, right? But if you have El Nino and you planted rice and all the rain is gone and you have deficit. So that way, El Nino and La Nina affect the Indian monsoon, which is very unpredictable and can sometimes go wrong. A lot of times can go wrong. And then IMD gets into trouble and everything. But that is Indian climatology.
There is a reason why there is a name of Rose Baby.
Why is it